All right, we're gonna just work through a couple more examples of dot product, thinking of dot product both kind of using our algebraic interpretation and our geometric interpretation. So if we have two vectors and we're asked to find the dot product, okay, well, pretty straightforward to do that. -3 times 2 is -6, plus -4 times -1, which is +4. -6 plus 4 is -2. So we know that the dot product, A dotted with B, is equal to -2. Okay. I also want to look at this one geometrically. Okay, so I'm going to try and sketch these vectors. We're going to think about the angle between them and go from there. This is also going to be good practice at converting something from its horizontal components into an angle measurement and a magnitude. Okay, so let's go ahead and do that first for both of these. So let's say I want to go from this guy, which is in horizontal and vertical component, over to thinking about this as a magnitude and a direction angle. Okay. Well, to find the magnitude, right? The magnitude is going to be the square root of the horizontal component squared plus the vertical component squared. -3 squared is 9. -4 squared is 16. 9 plus 16 is 25. The square root of 25 is 5. So the magnitude of A is 5. Okay. Now, if we want to think about the direction angle, well, there's a couple of different ways that we can think about this. Okay. The first way is to think about where this lies, right? So -3, -4. If I'm starting at 0, 0, it tells me I go left 3 and down 1, 2, 3, 4. Okay. So I expect my direction angle to take me in to the third quadrant. Okay. Now the other thing to think about, right, is I can think of my direction angle as a tangent operation. In other words, tangent of theta is equal to y over x. So tangent of theta is going to be equal to -4 over -3, in this case, 4/3. Okay. So if I take inverse tangent of 4/3, that's going to give me a starting place. What do I mean by that? Well, let's do inverse tangent. Oh. Inverse, yeah, no, we're not going to do that. Inverse tangent of 4 divided by 3. And that gives me 53.1. I'm going to round to 53 degrees. Okay, so doing inverse tangent here, so inverse tangent of 4/3 equals 53 degrees. Now that is not the correct answer. How do I know that that's not the correct answer? That's not the correct direction angle. Well, because 53 degrees would be here in the first quadrant, right? In order to get all the way to the third quadrant, I need to take 53 degrees and add it to 180, okay? So that just again has to do with what quadrant we need to be in. So 180 plus 53 is 233. So our direction angle is going to be 233 degrees, okay? All right, let's do the same thing with our vector B. So with our vector B, we first need to find the magnitude of B. So the magnitude of B will be 2 squared plus -1 squared. 2 squared is 4, -1 squared is 1, so this becomes the square root of 5. So the magnitude of B is the square root of 5. Okay. Now let's think about our theta, our direction angle. So in this case, I have 2, -1. So that means my vector is in quadrant 4. So I expect my direction angle to get me to quadrant 4. If it doesn't, I'm going to have to do a little bit of adjusting. Okay. Now our direction angle, we can think of as tangent theta, our direction angle, equals y over x, or in this case, -1/2. So I'm going to use my calculator to do the inverse tangent of -1/2 and see what we get. That gives me -26.6. So this gives me theta equals -26.6 degrees. Okay. Now that actually gets me in the right. Excuse me. That actually gets me in the correct quadrant, right? That -26.6 means I'd start here and go backwards. So that gets me to the right quadrant. But remember that a direction angle is always positive. So how do I go from this negative 26.6 to this whole angle? Well, I'm going to do 360 minus 26.6. So 360 minus 26.6 gives me my direction angle of 333.4. Okay? So my direction angle is 333.4 degrees. Okay? All right. So now, remember the other way we can think of the dot product, right? We can do the multiplication of the horizontal, multiplication of the vertical, and add those together. The other way we can think of the dot product, A dot B, is as the magnitude of A times the magnitude of B times the cosine of the angle between them. So here theta is standing for the angle between those two vectors. So let's go ahead and sketch out the picture that we're in right now. All right, so I'm going to sketch in A. So for A, excuse me, I'm going to go 233 degrees, so that puts me somewhere over here. So here is 233 degrees. The magnitude of this guy is 5. For my blue vector, okay, I have to go 333 degrees, somewhere over here. And its magnitude is the square root of 5. Now, the dot product tells me that I need the angle between these two. So I need this angle here. Okay. Well, how do I get that? Well, notice that that's going to be 333.4 minus 233, which is going to give us what? 100.4. So the angle between them is going to be 100.4 degrees. So our dot product, we could think of as the magnitude of A, 5, times the magnitude of B, square root of 5, times the cosine of 100.4 degrees. Let's see if that gives us the same thing. 5 times square root of 5 times cosine of 100.4. I get negative 2.01. It's close enough to negative 2. Remember that we had to do a little bit of rounding when we calculated these guys? Okay. So that again gives us negative 2. Okay, cool. It's really good that our two methods give us the same thing. We would break math otherwise. But I want to think for a minute about this idea of projection and think about what does it mean for our projection to be negative? Okay. Well, what does it mean for our projection to be negative? Remember, we're thinking about shining a light up here, right? So I want you to imagine if I shine a light up here and I'm trying to say project one vector onto the other, well, the way the vectors are, I'll get shadows, right? I'll get plenty of shadows, but this shadow is not going to go directly onto this vector, right? That's sort of what our negatives and positive are telling us, okay? Another way to think about the interpretation of the negatives and the positive is it tells us something about how our vectors are related together, or it tells us something about the angle between our vectors, okay? So what does that mean? Another way of thinking about this is if the dot product is negative, it means the angle between the two vectors is bigger than 100, okay? And that kind of makes sense if we remember that when the dot product is 0, our vectors or are orthogonal or perpendicular, meaning the angle between them is 90. So if two vectors meet and the angle between them is less than 90, their dot product will be positive. If they meet at exactly 90, their dot product will be 0. And if they meet at greater than 90, their dot product will be negative. So positive, 0, or negative. All of those are possible when we're doing a dot product. Okay, the last thing I want to talk about with dot product is, remember, we had these two vectors and we sketched them out and then used some logic to figure out the angle between them. Well, it turns out the dot product can also give us the angle between two vectors, okay? How is that possible? Well, remember what the dot product says. Our geometric interpretation of the dot product, right, says that we can think of the dot product, A dot B, as the magnitude of A times the magnitude of B times the cosine of the angle between them, okay? Well, I think from here, we can get all of these things. We can figure out A dot B doing the algebraic method. We can figure out the magnitude of A and the magnitude of B, which means the only thing we won't know is cosine of theta or theta. Okay, so we already found the magnitude of A, but let's find it again since I erased it foolishly. Okay, the magnitude of A, I can think of as my horizontal component squared. So -3 squared is 9, plus my vertical component squared, -4 squared is 16. 9 plus 16 is 25. And we're going to do the square root of that. So that gives me 5. Here we've got 2 squared, which is 4, plus -1 squared, which is 1. So the magnitude of B, not left-handed, is going to be the square root of 5. Okay, all right. So let's also think about A dot B as the geometric interpretation. -3 times 2 is -6, plus -4 times -1, which is 4. -6 plus 4 is -2. So we have -2, the dot product calculated algebraically, equals the magnitude of A times the square root of 5 times cosine of theta. Okay. Now can we solve this for cosine of theta? Sure. I'm going to divide both sides by 5 square root of 5. So that gives me that cosine of theta is equal to -2 over 5 square root of 5. Oh no, honey. Okay. Now to solve for theta, I'm just going to do inverse cosine. So I'm going to calculate inverse cosine of -2 over 5 square root of 5. Okay, so let's do that quickly. Pepper, do you want to help me? Like the calculator. So inverse cosine of -2 divided by 5 square root of 5, which gives me 100.3 degrees. Pretty close to what we calculated the other way. I think we calculated 100.4 degrees, so I think we'll take that. So notice this gives us another way of calculating an angle between two vectors when we have them just in their component forms. And that can be really, really handy.